Question 1. Let's just split this into partial fractions. So we should know it's a repeated root question that x minus 7, x minus 2 can be written, over x plus 2, x minus 1 squared can be written as something over x plus 2 plus something over x minus 1 plus a third fraction x something else over x minus 1 all squared. And our job is to work out a, b and c. First thing we do to work out a, b and c is times the left and the right side of this equation by all of the denominator of this, so that we're just left with on the left side x minus 2 and x minus 7. For the right side, that will mean when I times this term by all of this, the x plus 2 will cancel with this x plus 2, so I will be left on with a with x minus 1 all squared, with nothing on the bottom because these two terms have cancelled. For the b term, one of these brackets will cancel with this one, so I'll have an x plus 2 term and I'll have one x minus 1 term. And with the c, when I times by this, the x minus 1 squared terms will cancel and I'll just be left with x plus 2. Now it's going to be easier to work out a, b and c because we've got no fractions. And the way I usually work out a, b and c is by making sensible substitutions. You can do it by comparing coefficients. Both methods work fine. Comparing coefficients leads to you using simultaneous equations. Choosing sensible substitutions I think is a bit quicker. So the first sensible substitution I'm going to use is x equals 1, because that will make that first bracket disappear. So if I substitute x equals 1 into the left hand side, I'm going to have minus 6 times minus 1, and that's going to need to equal nothing here either because there's an x minus 1 term, but we'll have c times by 1 plus 2, which is 3. So here we've got that 6 equals 3c, so c must be worth 2. The second sensible substitution I'm going to choose is x equals minus 2. And when x equals minus 2, I'm going to have minus 9 times minus 4 is equal to this time this term won't disappear. When I put 2 into here, I'm going to have a bracket minus 3 squared. This term will disappear again because this time this part will be 0, and obviously the c term will disappear too. So we've now got that 36 equals 9a, which leads to us knowing that a must be 4. The third substitution can be anything you want. We've chosen the most sensible substitutions because it makes lots of these terms disappear. But I just need a third sensible substitution that will help me work out b, now that we know what a and c are. So it doesn't really matter what we choose. I'm going to choose, what should I choose? 0. So we're going to have minus 7 times minus 2 on the left equals, a we know is 4, so 4 lots of minus 1 squared. B we don't know, so b lots of 2 times minus 1. And c lots, and c is 2, so 2 lots of 2. So I've got 14 equals minus 1 squared is 1, so equals 4 minus 2b plus 4. Which means I've got 14 equals 8 minus 2b. So 6 is negative 2b, therefore b is negative 3. So that works out A, B and C for me, but we need to make sure we actually answer the question. We need to write down what the solutions are. So I'm just going to copy this, save me having to write it again. This is the same as, and let's make sure we get it in the right order. A was 4 and had the x plus 2 term on the bottom. So 4 over x plus 2. B, which is minus 3, which was the x minus 1 single term, plus C, which was 2 over x minus 1 squared term.